Biomedical Materials celebrates its 10th anniversary this year since launching in 2006. Over the last decade, that journal's developed to become one of the leading titles in the field, and later this month it'll publish a very special collection of articles featuring contributions from leading scientists in the field that collectively highlight some of the really key developments.
With us,
if you're a researcher who begins to get moved by the problem that certain patients have with some injury or disease, and you'd like to help them through the development of a biomaterial as an implant, the question is, where do you acquire the knowledge to begin to develop those materials, those medical devices? So it's important to know that you can go to a trustworthy journal to begin to acquire the information, the knowledge, to do what engineers do. Engineers use existing knowledge to make products for human good. And it's important to know, once again, that you can get that trustworthy information from a particular journal.
It's been a delight to be part of the IOP publishing family for this past 10 years. And we like to think that biomedical materials has been good for your health. If you're the publisher, IOP, we like to think that you take pride in the healthy impact factor that you've achieved, and that it validates the decision made 10 years ago to launch the journal. If you're a researcher trying to get your papers published, we hope that it's good for your academic health, that you can know that you'll get a fair but critical review of your paper and good ideas for how it might be improved. If you're a researcher looking to keep track of a research in your field, we think it's good for your academic health to know that where you can go to find leading edge research being published.
I'm a physicist. I've been always involved in doing research in semiconductor materials. But in the last 7 years, I moved to biomedicine, nanomedicine, using the nanostructures that I've grown in my group just to try to solve some problems. Nanostructures we grow in the group are silicon carbide based. We proved that they are cytocompatible, and we use them for different purposes. The main one at the moment is they act as scintillators for generating oxidative stress under X-ray radiation. We published a paper right now, and we proved in vivo that once you put these nanowires inside the cancer cells, the efficacy of the radiotherapy is 100% higher than the simple radiotherapy. I mean, if you use radiotherapy to treat the cancer, if you use the radiotherapy with the nanowires inside, properly functionalized to generate oxidative stress, the efficacy is twice with respect to the other one. So this is nice, it's promising, and this is the main idea. Then we have other ideas, but I told you that are under patent. We use our nanowires mainly. Okay, another idea is to use them as the core of a structure for artificial retina, for subretinal implants. This I cannot go more in details, I'm sorry about that. And also they can act as scaffolds for, teeth repairs and so on. And depending if they have a silica shell or not, they can be hemocompatible or not. So they can be useful for attracting plastings or for other purposes. It depends on how you engineer this kind of animal.
Most importantly, if you're a patient with some debilitating or life-threatening disease or injury, we like to think that you can feel that there's a place where people are publishing work that can lead to the medical device advancements that can actually help you personally. And if you're an editor-in-chief like me, it's good for your spiritual health, knowing everybody else is so healthy. So, thank you very much, and it's been a pleasure. We look forward to it.
The next 10 years, you know, I don't know that I could have predicted all the things that happened the last 10 years. So I'm as excited as anybody with what the expectations might be for the next 10 years. But I am very optimistic to some very devastating problems. Stroke, spinal cord injury, and retinal disease will in fact have meaningful treatments through the use of biomaterials-based therapies. And that's what I'm hoping.